Aish.
It's so hot today. Let's buy a drink.
Oh, there's a vending machine right there. So, Aloy, can you lend me some money? I forgot to bring it.
Here you go.
Alright. That's my boy. Yeah.
Thank you.
Aloy,
Thanks, bro.
do you ever wonder why the cans are still cool even though the weather is so hot?
I think the vending machine keep it cold.
Yes, the vending machine has the same concept as refrigerator.
Oh, really?
Yes.
Tell me about it.
Okay, let me explain to both of you how the refrigerator works.
Okay.
Okay.
Before that, let me tell you about the objective of our topic today. First, I will introduce the concept of refrigerator. Next, we will know the refrigeration cycle of refrigerator. We will also know how the refrigerator operates. We will understand how to calculate the QH, QL and COPR. Last but not least, we will know what is the application in our industry that use this concept. So, as you all know, the cans that kept in the vending machine and refrigerator will remain cool even though the weather is hot. Actually, the function of refrigerator are to remove heat from cold medium and to maintain the refrigerated space at low temperature. The refrigerator transfer heat from low temperature to high temperature. Refrigerator are cyclic device. The working fluids used in the cycles are called refrigerant. It seems like the concept of a refrigerator breaks the second law of thermodynamics. However, work can be used to transfer heat from the colder environment to a warmer environment. Below, a basic diagram of a refrigerator can be seen. From the diagram, it can be seen that a refrigerator consists of four basic components. There are a compressor, a condenser, an expansion valve, and an evaporator. Work is input into the compressor to compress the refrigerant to a high pressure as it enters the condenser, which is the network of tubes seen on the back of refrigerator. While the refrigerant is being compressed to a high pressure, the temperature also increases to a high temperature than the environment outside the refrigerator, which in turn will cause the outside environment to act like a sink. After the refrigerant has gone through the condenser, it will reach the expansion valve. The expansion valve will cause the pressure and temperature of the refrigerant to drop drastically. The temperature of the refrigerant will now be lower than the environment inside refrigerator. The cold refrigerant will then enter the evaporator, which is a series of tubes inside the refrigerator. As refrigerant flows through the evaporator, the refrigerator's environment will act like a source and heat will transfer into the refrigerator, causing it to evaporate. The refrigerant, which is now a gas, will enter the compressor again, where it will be compressed back into a liquid at a high pressure and temperature, and the process will repeat. So essentially, using work to run the compressor, the outside environment can be transformed into a sink where the refrigerator will dump waste heat, while the environment inside the refrigerator will become a source where heat will be transformed into the refrigerant. This all happens because of the cycle.
Yes.
Yeah, we get it.
Okay. But don't worry, next week during our thermodynamic class, Sheikh Hanafiz will tell us about this topic. So don't forget to come to his class, okay?
Alright. So Aloy, Alif, since you are always advanced in our class, so do you have any example that can help me? Maybe?
Yeah, I know actually. I have studied it last night. So, here, I want to show you.
Some example.
Yeah, same example. For the formula, coefficient of performance is equal desired output over required input, or we can call it QL over W net in. Coefficient of performance also equal QL over QH minus QL, because W net in is equal QH minus QL. And then COPR also equal 1 over QH over QL minus 1. For example, problem 1. To make some ice, a freezer extract 185 kJ of heat at negative 12 degrees Celsius. The freezer has a coefficient of performance of 5.70. The room temperature is 26 degrees Celsius. The question is, how much heat is delivered to the room? Question B. How much work is required to run the freezer? One of the regarding refrigerator.
Oh, now I fully understand about the concept of refrigerator. So, in our industry, the concept that is same as refrigerator is domestic refrigeration and air conditioning, commercial cool storage, ice making and skating rinks, and lastly, food or beverage processing. Am I right?
Yes, you are true.
Yes.
So, I think I can conclude all of these refrigerator things.
Refrigeration cycle.
Okay. So the conclusion is, the refrigerator use the concept of first law of thermodynamics. The most frequently used refrigeration cycle is the vapor compression refrigeration cycle. Refrigerator transfer heat from low temperature to high temperature, and the compressor is located at the back of the refrigerator and in the bottom area. The compressor sucks the refrigerant from the evaporator and discharges it at high pressure and temperature. The compressor is driven by the electric motor and it is the major power consuming device of the refrigerator. The condenser is the thin coil of copper tubing located at the back of the refrigerator. The refrigerant from the compressor enters the condenser where it is cooled by the atmospheric air, thus losing heat absorbed by it in the evaporator and the compressor. The expansion valve is the capillary tube in case of the domestic refrigerators. The refrigerant leaving the condenser enters the expansion device. The capillary is the thin copper tubing made up of number of turns of the copper oil. When the refrigerant is passed through the capillary, its pressure and temperature drops down suddenly. The freezer compartment where heat is absorbed by the refrigerant serves as the evaporator. The evaporator is the heat exchanger on the inside of the refrigerator that receives cold liquid refrigerant. So that is some of the conclusion regarding refrigerator that we will study next week. Am I right?
Yeah, good boy, Amirul.
Okay, thank you, Arif. So I think we should go back to our residential college. Yeah.
So,
What time is it, Alif? Yeah.
It's 10 o'clock, so it seems like it will rain. So let's go home, go back.
let's go.
Jom.
Do you want some water?